Let's hand this over to Ayden to the exciting part where he's actually going to walk through and actually show you some of this stuff in action. And then, of course, Dinesh will follow it up again with showing you how some of those applications can be driven from that, the things that Ayden's doing. And Ayden, I think you can kind of take control whenever you're ready.
Beautiful. Thank you, Tim. Just let my screen share here. Okay, let's dive into it. So to set the scene, I'm a marketing analyst. I'm at a higher end boutique store that's specializing in athletic wear, running equipment, hiking equipment, and I'm operating really globally through a business model that's focused exclusively online. Ayden, why are we choosing this scenario? Well, first and foremost, because we're actually fortunate enough to have real open source data from this company to really walk through this demo on, to test the mettle of WebFOCUS against. And then secondly, being a online boutique retailer, they're really looking to provide a personalized online experience, have a close relationship with each and every customer. So their objective actually when they released this data set originally was to get a deeper understanding of their customers, how they could be categorized, right, to offer better, more personalized offers, recommendations, customer experience, marketing, with the ultimate goal of increasing conversions and really seeing greater marketing ROI. So we began our journey on this humble dashboard, right? It's really representing an analyst's first pass at an operational dashboard capturing, demographic, geospatial, financial information, those sorts of measures. We've collected data from a few different sources, merged and pivoted our data in WebFOCUS, and have really built out this initial analysis genuinely for myself in a matter of minutes. And then in this data set, we have, information on each online session at our store over the last, I believe it was about a month. So the first, visualization here on the top left, that's really your fundamental visualization for funnel analysis, right? For the activity of each of these sessions. What page did the customer start or prospect start their session on? And how did they, what page did they close out on? Did they come to a conversion? Was it a loss? At which page did they end on? What's the home page? Did they reach checkout? And that's really what this visualization is talking about. So we can take a look at the funnel, where that customer ended by the page they started on, right? And then by the source of their traffic as well, right? Let's take a look at that split. Let me just move my webcam here. We can see there's a lot of organic traffic. Sure, that makes sense. We're seeing great success from our SEO, from our search engine optimization, but quite impressively, actually, we're seeing a huge number of traffic being driven by our social media campaigns, at least recently, because again, the timeline on this is about 30 days. So whatever we've been doing on social media, it's working, right? We're driving a lot of traffic through that source, through that avenue. And then looking at, the outcomes themselves, we're looking at, on this visualization here, about a 5% conversion rate, equating to 2,000-ish sales, 500 upsells, successful upsells over the last month. And then actually included in this data set is some simple marketing measures as well. So customer lifetime value, or CLTV, that's the estimated net profit from a certain customer, so one customer, over their entire engagement, their lifetime with our company. So from a lifetime value standpoint, we had customers with a combined CLTV of about, with this bar here, 9 million make purchases with us that were, customers that had registered, that had an account, that have engaged with us before, and then about 5 million in this green bar here of new customers, again, worth about 5 million with their customer lifetime value, engaged with us for the first time and then do that recently. And then, although we're a global company, the majority of this company's business is coming from the US, so incorporating geoanalytics into our dashboard is really critical in understanding, where our customer base is located, how we can best tailor, again, content, offers, products to each customer, right? And then lastly here, as an online first business, we have a really diverse customer base demographically, right? So looking at the average lifetime value by age, we can see there's a pretty strong, should be able to draw it here, my highlighter, a pretty strong positive correlation here between age and value, right? So we can see as we get in sort of the younger generation or younger customers, we have a lower estimated CLTV for them. But we're an athletic brand, right? Young adults are a key demographic for us. So this lower CLTV, maybe that's due to our marketing not being as effective to this group. Our website maybe not being appealing or friendly to this group. Our products themselves, hopefully, if that's harder to address, but if it's one of the first two, that's something we can act upon immediately and really, again, drive value from this base that we're not getting the value we should from. So to recap, again, this was our first pass at a dashboard to get a feel for that data set, right? Incorporate some operational intelligence. But remember, the goal of this exercise really was, and the goal of the company when they released this data set was to evaluate our current customer experience, our marketing campaigns, our offers, and really understand our customers on a deeper level so we can personalize all the above, right? And enhance our pipeline with tailored, targeted outreach. And the key to making that feasible really lies in customer segmentation, and that's the focus of the rest of this discussion. It's too difficult to tackle this problem in broad strokes, so we divide our customers into manageable groups based on their buying habits, demographics, location, engagement, and so on. That way we can measure how effective, again, any outreach, advertisements, offers are with each group, and then tailor any efforts to suit them towards the properties of each of those segments versus generic outreach to our entire customer base. And traditionally we can do this on a basic level with the info we already have, right? Distinguish between new and registered customers, for example, or split them by lifetime value, right? To get our sort of older, more loyal customers that we've been working with for a while, and our newer, sort of more at-risk customers. We can split by age, demographically, by location, because we have a bit of that geoanalytics involved. But top-performing companies are often combining that market intelligence with machine learning, with data science, to take their customer insights really to the next level and uncover latent characteristics in their customer data, which really often prove invaluable to funnel analysis and really any similar marketing exercises. So let me erase my highlighter here. To dig into this question, again, the focus of this session, we'll move away from the dashboard for a moment and take a look at what we're in right now, the reporting server window, specifically in the data flow view. So I'm sure some of you are familiar with this tool. Again, data flow allows you to extract information from data sources, merge, join, modify, enhance the data, and then load it into targets for future analysis and use. This is where I'd be writing my scheduled data extraction, statistical analysis, pre-processing, transformations, anything like that. And to that point, that's really sort of what the core tenet of WebFOCUS machine learning functions is. They're abstracted, you can see them listed here under train models. They're abstracted as, you can think of them as modules or operators within the data flow in the exact same manner as a join function or even just a simple SQL select. So analysts can work with these features using the WebFOCUS knowledge they already have, right? We don't need to reinvent the wheel. We don't need to install a separate tool. If you're working data flows already, you can get started working with these models immediately. And then of course, if you do want to dive deeper, you have the option to fine tune these models if you have some expertise there, tweak the parameters, even augment them with custom Python code. But at their core, they're no-code modules designed to be used by a WebFOCUS analyst with the expertise they already have and without DSML expertise per se. So before we jump into training the model, I'll just take another look at the data set itself. I'll make that bigger here for everybody. Each row here, again, it's an individual session. We have demographic information, stuff like location, source we talked about, where they're coming from, where that traffic's coming from, ads, search engine optimization, organic clicks, which page they started on. Again, we discussed that a little bit, where they ended their session, the outcome of that session, right? Was it a conversion, a successful upsell or not? And then those marketing measures we talked about. So customer lifetime value, we discussed that earlier, but also RFM measures. So really, how recently did they last engage your content? How frequently did they make purchases? Those kinds of measures. And now these functions on the left here, again, we're looking at this area here. They cover a wide variety of models, and between them, they really capture the vast majority of predictive use cases you might want to enhance BI analysis with. Classification, right here, that's the top one. That really covers categorical predictions, so churn prediction, for example. As long as I have a data set of churned customers, I can train this model and run it against new data sets to identify churn risk, right? Regression, similar to classification, but for numeric measures. So think of predicting percentage likelihood to accept an offer, right? Predict how page authority for search engine optimization relates to organic page views, something like that. And then anomaly detection and time series forecasting at the bottom there. They're both relatively self-explanatory. Anomaly detection, that would be finding outliers in your data, assigning an anomaly score to each data point, and then making temporal predictions for time series forecasting. But the star of the show here, it's the one in the middle, that's clustering. I've gone through a little bit of sort of technobabble relating to all these different models, but clustering boils down to basically one goal: splitting my data, in this case customers, into separate groups based off of the salient features of my data set, of course, but also latent characteristics that might not be apparent to a human looking at the data, right? That's really where the value of this model comes from. What's special about clustering is that it's an unsupervised algorithm. What does that mean? Well, for churn classification, you need a separate training set. You need to have data on customers that have already churned and ones that haven't, right? And feed those labels to the model for it to learn. It can't detect churn if it's not given data with explicit churn labels in its training. Unsupervised algorithms like clustering, though, aren't given any explicit labels, right? I'm just giving it my data and telling it I want to find patterns in that, right? And then again, in this case, it would be groups of customers with similar characteristics, because that's how we divided our data. But I'm not feeding it any labels or sort of coaxing it at what I want to look at. I'm asking it to find the patterns itself without input from me as the analyst working with these tools. And in a bunch of industries, I mean, manufacturing for sure, supply chain, even retail examples like this, the vast majority of data is unlabeled, right? It's not ready to be ingested by some supervised algorithms. So unsupervised models like this are essential in uncovering more about your data, especially when you're dealing with huge volumes of data that aren't curated as a training set or haven't been, neatly annotated. So with that background, let's build the model, right? To create a clustering model, all I need to do is click on it here and then select which columns I want the model to take into account. I'll deselect user ID there. I don't want it, making groups of the customers based off of what their ID is. And then I just click apply and give it a run. This should take about a minute to run. It's a 10,000 record subset of the full data set, which is about 150,000 records. I'll show the model trained on the full data set when we hop back into the dashboard, but that model takes about 3 minutes to run, and I didn't want to make everybody wait so we can get to the output. While we're waiting for this to train though, let's do a quick poll. Again, I'll give everybody 30 seconds here just in the interest of time, but if I open this up, should have launched. Which of the following use cases do you think can be tackled by clustering? Fraudulent activity, document analysis, and then insurance premium calculations, or all the above. So just click on one of the answers there. It should automatically go in, and I'll close the poll here when the model's finished training. I know it's a quick amount of time to hit you with a technical question. So, if you come up with a question after we close the poll, no worries there. Give it a few more seconds. And close. Let's share the results. So 57% of you said all the above, and you are correct. Fraudulent activity, right? I can cluster my customers or my sessions or my purchases into what's normal, and then based off of that, figure out what's not normal, what's anomalous, what's fraudulent. So clustering is actually used for anomaly detection, for fraud detection in many cases. Document analysis, that's a really common use case for clustering. I have a bunch of documents that I don't have labels on. Let's use clustering to group the documents based off of their properties, their titles, the text themselves, to really, get a better feel for, a vast database of documents that I don't have labels for. Insurance premium calculations, that's even another example, is if I can group customers by their buying habits, I can group insurance customers by their living habits, by their risk factors, anything like that, and then really, formulate groups for premium calculations. So the correct answer, all the above. These are all great use cases for clustering. I'll hide the poll there so we can hop back to WebFOCUS. So we've trained the model. It's found 4 clusters, 4 groups of customers that we can target separately and fine tune our outreach towards, right? But let's see what those clusters represent first, and then what information they're capturing so we can bring that back to our broader analysis. First, we'll take a look at cardinality. So we can see the clusters, they aren't evenly distributed. The majority are in that 4th cluster there. Let's keep that in mind as we sort of explore which customers fall into which cluster. And really to get a feel for how these customers are divided, we can take a look at the projections tab. So what does this tell us? Right now it's dividing by recency and frequency. Again, that's from our RFM analysis. These are basic marketing measures. This does a decent job of capturing what differentiates 3 of our 4 clusters. You can see dark blue here at the top. That's really our one-off, less frequent customers. Green, that's our high-value regular customers that have also engaged with us recently. Light blue here, they're high-value customers, but they're at risk. They haven't engaged with us. Again, the split looks like about 160 days, so about half a year. They haven't engaged with us in that time, so they're likely at risk. So we're already seeing some, interesting segments that the model's found. What about that last cluster though? There's 4 clusters, the one in purple. It doesn't seem to be, neatly divided by these 2 measures. It's all over the place. So to get a better understanding of that, we can take a look at the coordinates of each cluster. This shows us the median value of each cluster, right? To tell us which variables or fields are most important in differentiating between clusters. So cluster 2 there is the purple one. I don't know, it might be a little hard to see, a bit of an eye test, but I'll give everybody a second. Does anyone see sort of what differentiates it? It wasn't recency and frequency, those first 2 measures, but some other measures might have shed some light on what the model is splitting those clusters by. So take a quick look at these measures. We can see cluster 2 captures younger customers, right? Their average age is 26. We spend more time shopping. Again, I think this is in seconds, so 883 seconds compared to an average session of 124 sessions. We can also see that they have a lower CLTV, right? That ties into the analysis we saw in our first dashboard. So again, they're probably an important demographic for an activewear company, but we're not capturing that value. So this 4th cluster has really found that segment of younger customers that spend more time shopping and that we haven't captured the value of. So we've got a good initial feel for our model, but let's go back to the dashboards to dive a little bit deeper into what those clusters represent, and then most importantly, how we can act on those, how we can derive value from those insights. Again, the model, give it a refresh. Let me reopen it here. Cool. So our initial model was only trained on that 10,000 record sample, right? The full data set here is a model trained on 150,000 records. And the first thing to note here is that the models found 5 clusters, not 4. And that's shown here on this top left visualization. This is, again, your typical funnel analysis visualization. it's capturing where each customer ended their journey on, what page they ended on. Was it the home page, a product page, checkout? And as we go across these clusters, we can see the proportion of where these customers are ending is pretty similar, except for the 5th cluster there. We can see a much larger proportion of this 5th cluster are ending on the returns page. So we'll have to dig into that a little bit deeper. The scatter plot here is showing us on the right customers by lifetime value, by recency. Again, when was their last visit, with the size of that bubble really reflecting how often they visit the website. This is telling us clusters 1 and 2, that would be the green and blue there, are higher value customers. The 5th cluster seems to be visiting more frequently, but again, we haven't been able to capture the value of this customer group, right? At least based off of our lifetime value estimates. So again, that's something we need to explore more. I'll skip the map here for now, but again, we can take a look at, oh, there we go, it's taking a load. It's not important in this case, I'll say that. There's not a whole lot of differentiation based off where in the country they are. But in a lot of industries, for example, my work with the financial sector, an important consideration is which branch or location a customer or a member of a bank or a credit union belongs to, right? Both in analyzing how that location compares to others, but also in the purchasing habits of customers, right? In that area, in that geographic area, which offers speak to them the most. And now I have a confession to make. I've deceived you all a little bit up until this point. In our discussion of clustering models, let me just relaunch everything here. Let's take another look at the dashboard. And we're going to the 3rd tab here, model comparison. So in our discussion of clustering models, we mentioned that in most use cases, you would not have a benchmark to directly test the model's efficacy against, right? That's the nature of an unsupervised model. But this data set was actually manually annotated for marketing with sort of some rules-based decisioning augmenting it, but mostly a manual process assigning 4 different labels to each customer in this data set. The model did not see these labels at all, right? It was given what you saw in the training session, but this gives us a really unique opportunity to see, how our model compares to these manually curated labels. We're looking at the bottom right here. We can see, let me grab my highlighter out. Here, we can see each customer was given one of 4 labels. So at risk, that's this top row here. Loyalists, or most valuable customers that engage with us frequently. New customers that aren't registered, don't shop with us on a regular basis, and then potential loyalists at the bottom there. So new customers that show promising engagement and value and are really good candidates for outreach to convert them to loyalists. And so what this visualization is showing us is that the clusters themselves map to these labels decently well. If we look at the first one here, at risk, we can see 80%, and that's the 3rd column here, 80% of our at-risk customers have been mapped to cluster 3. About 73% of our loyalists mapped to cluster 1. 88% actually of our new customers mapped to either cluster 4 or cluster 5. And then lastly, about 64% of our potential loyalists are captured under cluster 2 here, with a significant portion under 4 and 5 as well. And that makes sense because, again, potential loyalists are new customers that are the best candidates for marketing outreach, for offers to increase engagement, really convert them to a loyalist. So let's pause here for a second and reflect on that. I mean, this model, which took around 3 to 4 minutes on the full data set, has relatively accurately captured what was manually curated on 150,000 data points, 150,000 user sessions. And not only that, it's also potentially found new patterns. I mean, differences that weren't present in the initial labeling, right? One obvious difference is the number of clusters. There's 5. there's only 4 labels, right? There's this distinction in new customers between the 4th and the 5th cluster. So why has our model differentiated between them, right? We saw in our initial analysis that 5th cluster had a larger number of customers leaving on the returns page, but let's dig into that difference a little bit deeper. I mean, again, let's see what additional insights our models uncovered here. Let me get rid of my scribbles. Everybody wants to see that over the next slide. Let's go to our last dashboard here. Okay, so we saw in the previous visualization, cluster 4 and 5, they account for combined, I think it was 88% of our new customers, right? Or what was labeled as our new customers by the manual annotation. But what's the difference between them? Again, why did the model differentiate between these two groups, and how, most importantly, how can this guide our marketing outreach, our funnel strategy going forward? So one of the answers is in the ratios of sources. So organic, direct, SEO. Cluster 4 matches the proportion. This would be a bit of a memory check, but back on our first data set, matches the same proportion, similar proportion to the other clusters and to our broader data set. But we can see here, cluster 5, there's a much larger ratio of traffic being driven from social media. Again, that's worth exploring more. Let's figure out what this 5th cluster represents and how we can target them effectively. We can also use this bottom visualization here to map out these two clusters. So this is showing us the average session time by the age of our customers. I've written down in my notes here the centroid, which is the median value for each of those clusters. I'll pull up my highlighter again. For cluster 4, it's around here. And for cluster 5, it's around here. So again, cluster 5 is really defined as this younger group of customers who spend more time on our website, and again, who for some reason are leaving more on the returns page. And that's exactly the demographic we are looking to capture, right? That's going back to our very first dashboard. We saw that, you know, we're an athletic brand, right? We should be capturing this user base, and we're failing to do so. So how do we rectify that? How do we act on that? And then it's told us again, they spent longer on average each session, and for whatever reason, they have a higher proportion leaving on the returns page. Okay, so takeaways. How do we act on this information? Well, this model is saved in the reporting server. It's a master file like any other. So we can run that as part of any flow. So every time, let's say you bring in a new customer, we can run this model against that and then divide them into a cluster. So we got our new, batch of customers. Let's put them all into one of these predefined clusters based off of, our model's initial training set, and it can be sitting there in your regular data ingestion flow to augment it with this additional information. But we can even make decisions based off of this, right? For example, email outreach, right? If they're potential loyalists or at risk, we probably don't want to be sending the exact same material to both of those groups. So we define which cluster they're in. We plug this model into, our new data set, assign this cluster, and then change, alter, tailor our outreach based off which cluster they fall under. Or even, as the customer is browsing a website, right? We send alerts or communicate with an API to send an offer to that customer, let's say that's categorized in cluster 5, to offer them, free, no questions asked returns, right? Because that seems to be a sticking point with this group. I don't know, maybe the younger people here are smarter shoppers, something like that. Probably not, but maybe. And the power of this is that it's all in WebFOCUS, right? So you could get started including these models and their insights in your WebFOCUS dashboards, in your reports, in your flows today if you really wanted to. And I know I'm running a bit over, so I'll wrap it up here. I'm going to hand it over to Dinesh. He's prepared some awesome material on implementation strategies and some excellent marketing dashboards there as well.